Prepare to have your mind blown as we embark on a mind-bending expedition to explore the bizarre realities that await us at the end of the universe. From mind-expanding concepts like heat death and cosmic loneliness to mind-boggling theories of collapsing universes and parallel dimensions, the grand finale of existence is a captivating enigma that will leave you questioning everything you thought you knew. Get ready to confront the mind-bending possibilities that lie beyond the boundaries of time and space. Our universe is going to die, no doubt about it. One of the most accepted models of the end of the universe is eternal expansion and eventual death by entropy. As the universe continues to expand, entropy increases until everything we know is gone. But what does life look like as the end approaches? That question has given rise to fascinating ideas about the universe and life itself. Here are 10 bizarre realities of life at the end of the universe. 1. No stars visible from Earth. In 150 billion years, the night sky from Earth will look very different. As the universe races to its heat death, space itself will start to expand faster than the speed of light. Many of us are aware of the idea that light speed is a hard limit on the speed of an object in the universe. However, that only applies to objects that are in space, not the fabric of spacetime itself. This is a hard concept to wrap our minds around, but the fabric of spacetime is already expanding faster than light. And in the far future, it will have strange implications. 2. Our sun becomes a black dwarf. Right now, our universe has many different types of stars. Red dwarfs, cool stars that give off red light, are among the most common of these. Semantically related white dwarfs also fill the universe. These are stellar remnants of dead stars made of degenerate matter that are held together by quantum effects. Currently, astronomers consider white dwarfs to have essentially infinite lifespans. The universe is just not old enough for them to have died out. But given enough time, even they will die and become exotic stars named black dwarfs. Our sun is on that path. In the distant future, our sun will eject its outer layers and turn into a white dwarf star, staying in that state for billions of years. As the universe winds down, the white dwarf that was our sun will start to cool. After 10,100 years, it will cool down until its temperature is equal to the background microwave radiation, just a few degrees Kelvin above absolute zero. 3. Weird stars. By the time our sun becomes a black dwarf, stellar evolution will be over. No new stars will form. Instead, the universe will fill up with cold remnants of the stars. That will allow the universe to start developing some odd stars that are quite different from what we know. One is the frozen star. As the stars of the universe burn through their nuclear fuel, they will increase their metallicity. In astronomy, this is the measure of elements in a star that are heavier than helium, all the elements from lithium-ion. As the metallicity of the stars increases, they will get colder because heavier elements give off less energy from fusion. Eventually, stars will get so cold that they will have a temperature of 273 Kelvin, the freezing point for water. 4. All nucleons decay. Fast forward from 10-15 years after the Big Bang to 10-34 years. If the human race is not dead by then, we will certainly not survive this era. As mentioned above, astronomers constantly argue about whether proton decay will occur at the end of the universe. For our purposes, we will follow this model. Nucleons are the name given to the particles, protons and neutrons, inside an atomic nucleus. Free neutrons are known to decay with a half-life of about 10 minutes. But protons are incredibly stable. Nobody has observed evidence that they decay. That will change at the end of the universe. Physicists have proposed that a proton has a half-life of 1037 years. We have not observed them decaying simply because the universe is not old enough. Entering the degenerate era, 1034 years to 1040, protons will finally begin to decay into positrons and pons. By the end of the degenerate era, all protons and neutrons in the universe will be gone. 5. Black holes dominate the universe. When nucleons are gone, black holes will finally dominate the universe from 1040 years after the Big Bang to 10,100 years. At this point, we are talking about times so long that our minds can't wrap around them. But for a period longer than the universe has existed so far, the only structures to speak of will be black holes. With nucleons gone, the main subatomic particles will be leptons, such as electrons and positrons. These are what will fuel the black holes. As they consume the remaining matter in the universe, black holes will radiate particles on their own, which will refill the universe with photons and hypothetical gravitons. However, as Stephen Hawking proved, even black holes are going to end. 6. A new type of atom forms. After our universe has turned into a few scattered subatomic particles, it seems like there won't be much to talk about anymore. But life may emerge in this most unlikely of places. For years, particle researchers have talked about positronium, an atom-like bonding of a positron and electron. These two particles have opposite charges to each other. The positron is the antiparticle of the electron. That means that they will be electromagnetically attracted as they attempt to move toward each other. When a pair of these particles begin to interact, they could develop rudimentary orbits and behave like the atoms that we know. Since positronium is rare, there is not a full model of positronium chemistry. But a few interesting things come from these odd atoms. First, they can exist with extremely large orbits, spanning interstellar distances. As long as the two particles are interacting, they can form a pair regardless of the distances. 7. Everything happens extremely slowly, including thought. As the black hole era comes to an end and even these stellar giants disappear into the blackness, there will only be a few things left in our universe, mainly diffuse subatomic particles and the remaining positronium atoms. Once this happens, everything in the universe will occur extremely slowly, with every action lasting eons. According to some theoretical physicists, mainly Freeman Dyson, life may recur in our universe during this time. Given the immense amount of time, organic evolution could begin to develop among the positronium. The beings that emerge would be very unlike anything we have seen. 8. No more macrophysics. By this point, the universe will have reached a nearly maximum entropy state, meaning that it will be just a uniform field of energy and a few subatomic particles. This will be after the black hole era, expanding deep into time past 10,100 years in the future. At this point, space will have expanded so much and dark energy will be so powerful that even black holes will no longer exist, and the universe will no longer have any massive stellar objects. It is hard to imagine a universe like this. The expansion will have been so pronounced by this point that stars as we know them will no longer form because the subatomic particles that form matter will have been pushed so far away from each other that they will not be able to interact without traveling faster than light. All that will exist is a few stray particles that will float around the empty cosmos, not even able to interact to form positronium atoms. 9. There might be a way out. So far, our journey to the end of the universe has been an increasing series of bleak and depressing events. But physicists are nothing if not optimistic and have proposed ways for the human race to survive the end of time and even start our universe over again. The strongest possibility for escaping our maximum entropy universe is to use black holes before proton decay makes life impossible. Black holes are still huge mysteries, and theorists like Stephen Hawking have proposed using these massive objects to get to new universes. 10. Random quantum tunneling may start it all over again. But what about the universe we leave behind? Over a huge amount of time, it would finally reach maximum entropy, becoming completely uninhabitable. However, even in this dead universe, there is a chance for life to recur. Researchers of quantum mechanics know about a quantum effect called quantum tunneling. This is when a subatomic particle can attain an energy state that is not classically possible. In classical mechanics, for example, a ball cannot start rolling up a hill spontaneously. That is a forbidden energy state. Subatomic particles also have forbidden energy states in classical mechanics, but quantum mechanics turns that all on its head. Sometimes particles can tunnel to these energy states. As we reluctantly come to the end of this mind-bending journey through the bizarre realities of life at the end of the universe, one truth becomes starkly apparent. The cosmos is a vast and ever-evolving enigma that defies all notions of time, space, and existence. From the mind-boggling concept of the heat death of the universe to the eerie solitude of a dark and empty cosmos, each revelation pushes the boundaries of our imagination and challenges our understanding of reality itself. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.